2016 B1. Okay, so the image on the right shows a restaurant which consists of a series of intersecting triangular glass surfaces. B1 shows the plan and elevation of 4 such intersecting planes. Data related to the horizontal and vertical coordinates of A, B, C, D, E, and F, defining the 4 planes, are also given. So remember, in, up, down. The numbers aren't massive, so we can pick a point on the page and call it 0 and get the in, up, and down. So we don't have to rename any of the points. So what I need you to do now is you're going to draw the elevation and plan of the surfaces, given the intersections of ABC, ABD, and DEB. You will see there's a measurement missing for F. That's this height, you haven't been given it. So you can't draw that triangle, you can only draw these 3. So as you would have seen, the dihedral angle is 170 degrees between the 2 surfaces here and here. And we're going to use that dihedral angle in order to calculate the height at the very end. So at the moment, what I'd like you to do is find the positions of A, B, C, D, E, and F. Okay, so you're going to start off with your XY line in the middle of your page as best you can. Grab your set square and start measuring. So 130, 160, 100. Pick a point on your page to start. That will be your 0. And from it, you'll measure all of your other distances. So I'm using 1 as my 0 point because 0 is actually a little bit off the set square. So I'm using 1 or 10 as my starting point. So for 130, it will be 140 for me. Okay, with those positions in mind, do vertical lines to represent the elevation and plan of that point, and we'll measure the heights in a couple of moments. Now the heights are 40 and 85 and 30 and 70 and transfer all of those measurements across your page and find them on the correct lines. So A is 40, B and C is 85, E is 70, D is 30, after joining that wrong, apologies. Thought A was the lowest point, it's not, D is. So apologies for that. So A is 30. A, sorry, is 40 and D is 30. Okay, apologies for that. Okay, and just label them out. A, C, B, E, D. And as I said, we don't know where F is, so we can't draw it in just yet. We can now do the plan. Okay, and just measuring the plan distances. So it's 80, 35, 35, 75, 25, 55. So 80 for A. 35 for B and C. D is 75. E is 25. And F is 55. And again, we join up all of the points. And label them accordingly. Okay. Okay, great. Now that we've that done, we are now going to, that's part A of the question done. Part B of the question is determine the dihedral angle between the planes ABC and ABD. Again, there are 4 steps in completing the dihedral angle. Okay, so the first thing we need to do is find the line of intersection and get the true length of this line. This is your first auxiliary. So with that in mind, it's between the surfaces ABC and ABD. ABC and ABD. Checking them in plan, this is the line of intersection. It doesn't matter if you do the auxiliary above or below on the page, as long as you have enough space to do so. With that in mind, my XY line is going to be parallel to the line AB because that is my line of intersection. So draw your XY line in and label it X1, Y1. You would have learned that when you take this auxiliary and get the true length of AB, that you needed 2 other points, one from surface ABC and one from surface ABD. That means I need to bring out C and D into this auxiliary as well. So I'm going to do that because you should be familiar with this at this stage. Okay. This is my first auxiliary, and in an auxiliary you always work from your last XY line back. With that in mind, you're going to take heights from your elevation. So grab your compass and you're going to take all of the heights from the elevation. So for A and B, first of all, so A was 40 high, but you take the 40 from your elevation, transfer it into your auxiliary, take the distance for B, which was 85, I think. And the first thing I'm going to do is I'm going to draw that line AB in heavy, because that's what I've been looking for this part of the question, was the true length of the line of intersection. And again, I'm going to bring C and D, or measure C and D out in this view as well. So C and B are the same height, so I'm just going to actually transfer the exact same height by drawing a parallel line for C. Okay, so there's C. And then D was a height of 30, which I can measure again from the elevation. And usually that XY line will be heavy, so I'm just going to make sure it's visible on the sheet as well. So that's your X1, Y1. Now that we have that, and we have the 2 points out in that view, we need to now look along the true length line of intersection and see it as a point, along with those 2 other points, so we can measure the angle. So by looking along it, we're bringing out all those points at this angle, at the same angle as the true length line. Bringing out D and C also. And drawing a new XY line. The XY line can be close actually to that true length line, doesn't matter. But this is your second one, so call it X2, Y2. And in the auxiliary, you always work from your last XY line back. So grab your compass. So this is my new XY line. My last one was here, and I'm working backwards. So the distance to C is actually quite small. Sometimes it can be quite hard if you keep it so close to measure on your compass, but do the best you can. If you can't measure it, you can measure it with your set squares. Okay, so that's that distance transferred from the XY line. Then we're going to take the distance to B and A. It's the same distance, and that's why it appears as a point. So for A and B, get your distance. And finally for D, get the distance back to D. And from your new XY line, strike it off. And all we're going to do now is join the 3 points together. So I'm just going to label this so people can see clearly. So this is A and B. This point over here is C, and this point up here is D. AB is the center of the angle, and I know you actually can't physically see D. So join D to A and B, and join C to A and B. And like you've seen time and time again, you're going to measure this angle. But we're going to show it as dihedral angle using the symbol that I've shown you on the sheet. So the 2 little triangles and the dot in the center. Grab your protractor. Now I'm getting an angle of 165 degrees. And remember, it's plus or minus 5 degrees of that number. So some people might get 170, some people might get 160, but anything in between plus or minus 5 degrees. Okay, so that was part B of the question. Part C of the question, I'm just going to read out from the exam papers. So we've drawn the elevation plan, we've done the dihedral angle. It says, draw the elevation and plan of a horizontal line on the surface DEB and then to determine the true inclination of the surface DEB to the horizontal plane. So it says, draw in the elevation and plan a horizontal line. Now in elevation, a horizontal line will always look horizontal. On the surface DEB and then determine its true inclination to the surface DEB. This sounds a lot more complicated than it actually is. Just make sure that you use the surface that they're asking, which is DEB. So I'm just going to highlight it for myself. It's this one here. And I'm going to do this in colour so you can see it. So in some parts of a question, I might not have gone through how to do it, but it's telling you what to do. And you're asked just to follow your instinct and do what you're asked. So it says, draw a horizontal line on the surface DEB. The smart thing to do is use one of the vertices. Now, if I try to draw a horizontal line from D, it's not going to intersect on the surface. Likewise, if I try to draw a horizontal line from B, it's not going to intersect on the surface. So if I want a line to be on the surface using one of the vertices, I have to use E. So at E, draw a horizontal line. Okay, so that is a horizontal line on the surface E. Like in maths, whatever you do in elevation, you must do in plan. So a horizontal line in elevation may not necessarily be a horizontal line in plan because the line could be turned. So if I know in plan, like it's going to look like an angle line like that, but in elevation, it's going to look horizontal even though it is turned. Okay, so that's how elevations and plans works. So this point, I'm going to call it Q for this. Doesn't really matter what you call it. But that point, it's on the line BD. And I can find that point on the line BD and see that those 2 points are joined together. And I'm going to do whatever I did in elevation, I will do in plan. So I'm going to find Q first of all in plan, which is on the line BD. You can see that E and Q are joined together, so I must do the same. Now, I have drawn a horizontal line in elevation and in plan on the surface DEB. That's finished. But it's just asking me then, and then determine the true inclination of the surface DEB to the horizontal plane. So I want to figure out, here's my plane, and I want to see what angle that is actually tilted at to the horizontal plane. Well, because I have a horizontal line on it, if I look out along that horizontal line, I'm going to see this whole plane as an edge. And I'll obviously have the angle to the horizontal plane then. Okay, so I have half of the question done. It said draw a horizontal line on the surface, which I've done in plan and elevation. And I now need to get the true angle of it. To get a true angle, true width, true height, you have to do auxiliaries. So it's an auxiliary that we need to do now. I do not have space down the page because my first auxiliary, well, my dihedral angle question is there, so I need to go up the page. So I'm taking an auxiliary and I'm looking along the line DQ or EQ, and I'm going to see that line as a point. I'm going to draw an XY line, and this is my third one. So this is X3, Y3. And I'm going to bring out all of the points D, E, and B onto that surface. Okay. Now, out here, we have to work from our last XY line back. For this drawing, our last XY line was here, and back is just up the page. So we're taking heights again. So grab your compass. You can see now from your elevation that Q and E are the same height. So when I look along it, Q and E will end up as being one individual point. If I'm accurate, these 3 points will all be in a line, and that's the angle at which the plane is resting at. So I'm going to take the height of D, and on my line D, I'm going to strike it off. I can take the height of E or Q, it's the same thing because you're both the same height. And again, strike it off. And then finally, I'm going to take the height of B and strike it off. Now, I have 3 individual points which I'm going to label now. So I have D, Q and E, and B. If I'm accurate, they should all be in a pretty straight line, and look at that, it's perfect. Okay, so this whole triangle, this one, I've transferred it into a line. Okay, there it is. So I'm looking at the edge of it. Now I'm asked to determine the true inclination of that surface to the horizontal plane. Well, this is the horizontal plane, and I want to figure out what that angle is. So I could, if I wanted to, do a parallel line here and measure the angle on the inside, or I could continue this plane down on till it touches the ground, and I can measure the angle inside here. These 2 angles will be the same, so it doesn't matter what way you do it. I think it's more accurate to just do this because you're just continuing on the line, and you can measure the angle straight away without having to draw an extra line in. Okay, so I'm just going to get rid of the angle and this unnecessary stuff that I put in there a second ago. And I'm going to measure the angle of that plane to the horizontal plane. Now I'm getting about 50 degrees, maybe around 51 degrees maybe. On mine it's 51 degrees. You might have something between 50 and 55 or 45 and 55. Anything plus or minus 5 degrees is fine. It's probably meant to be 50. Now I got 51 just on my drawing. Okay, so that is part C of the question. I've drawn the horizontal line in elevation and plan, and I've got the true inclination to the horizontal plane. The last part of this question is asking you to get the dihedral angle between the planes DEB and DEF. That's these two planes, and this is the line intersecting them. There are 4 steps in doing the dihedral angle, and the reason that you need to do this dihedral angle, you've been given it, it's 170 degrees. The reason you've been given it is so you can complete the elevation to find where F is. Okay, we would have done a question very similar to this on Monday, so we're just continuing on and finishing this off. So here is my line of intersection between the two surfaces. It means that my XY line is going to be parallel to this, and this is my 4th XY line. So this is X4, Y4. Keep it away from the object. It's okay if this is overlapping, but if you're conscious, you can keep it away. So this is X4, Y4. And we're going to bring out D, E, B, and F. F I obviously can't measure, but I can measure everything else. So don't worry about it too much. Now take the heights of all of those different points, D, E, B. So B is 85 in height. E 70, I think. F I don't know, but D is 30. Now my true length line is DE. Just be careful with the labeling. So this is D. I'm just going to do it in heavy. D, B, E. And this is the line for F, which we can't do anything with at the minute. Okay, so it's D and E, that's the line of intersection, so join those 2 points together. Okay, B is a point that's on the surface of DEB. And obviously F is another point, we can't get it yet. So we have done the first auxiliary. Okay, we now need to look along the true length of the line of intersection to see it as a point with 2 other points. We then measure the angle. Now we only have 1 point at the moment. As you can see, I might need to stick on a sheet just because this could go off my page. I don't really know just yet. But if we need to, it's very simply just stick on a sheet. Now, look along the line of intersection. Bring out the other point. Draw your XY line close. Sorry, now I think my sheet moved by accident. No, it didn't. Keep it close. This is my X5, I think, now at this stage. Yeah, X5, Y5. And I'm going to measure all the distances back now. The distance back to F, the distance back to D and E, and the distance back to B, because I have all of those measurements. Looking at it now, I think B is going to go well off my page. Find something to stick on. Okay, so if you need to, just grab a page to stick on there. Okay, so as I said, in this auxiliary, you measure from your last XY line back. I said take all of the measurements back to D, E, B and F. So D and E first, take the distance, strike it off. That's D and E. Take the distance back to B. And this was the one that I said was going to go off the page, which it has. Now, my line needs to be extended. Okay, so there's B. And I said also take the distance back to F. We've drawn two lines at the minute. It doesn't matter which one you put it on. Just strike it off. So that's the distance back to F. But I'm going to do a line parallel to the XY line because F, I don't know where it is, but it's going to be somewhere along there. It's when I measure the angle, I'll then find it. So F is going to be on this line somewhere. It's when I measure that 170 degrees, which I was told in the question. I'm just going to prove that I was told that in the question. So the angle is 170 and you're asked to complete the projections. That means complete the elevation. Okay, so we can now measure that 170 degrees. So join B to D and E. You are then going to grab your protractor. The difficult thing about this is trying to figure out where the height will go. Now, if I do 170 in this direction, I'm just going to do it in lightly for you to see it. I'll get a point here somewhere. And when I bring it back parallel, F is really high. And F is not going to be higher than D. It needs to be lower. So I need to turn the protractor the opposite direction. And this is trial and error every single time. Measure the 170. Put in your dihedral angle symbol. The little dot in the center. And where the 170 line crosses the line for F, that's where F actually is. When you have found F, you need to bring it back into the previous views the exact same way as it has been transferred out. What I mean by that is, from this auxiliary into this one, they came at this angle. So F needs to be brought back at the same angle. So slide your set squares parallel to DE, apologies. And when you bring F back along in the line of F, you get the height of F. So from F back to the XY line, that height, we're going to transfer it because in this first auxiliary, we took the height of D and E from here, the height of D and the height of E. So that means obviously this distance has to be a height for F. So take your compass, transfer that height into your elevation, and that completes this question. I'm just going to show that in red again, so that this distance and this distance is the same, and then complete the projections, which means complete the surfaces or complete the drawing is done. Okay, so this was the 2016, I don't know where we have space on the page, 2016 B1 dihedral angle. Okay, so the dihedral angle question.